So for my project, or poster, I'm doing it on the Gearbox, and in this poster, it's to illustrate and explain the components and the operational purposes of a manual gearbox system, along with its gears and the gear transmission operation within a modern day gearbox design on a vehicle. And figure 1 shows a typical manual gearbox system and the differences between the selecting of first gear and third gear. The background of the gearbox is in modern internal combustion engine. There is a limit within the system to operate at an effective speed range between 1,500 and 5,000 revs per minute. In this range, the torque or the turning effort of the car speed will drop below the lower limit, or if the load is much too great, it will cause an engine to stall and in effect stall the vehicle. If a vehicle is not fitted with a gearbox, the following disadvantages would arise. Number 1, poor acceleration from rest. The clutch must be slipped for a considerable amount of time to avoid stalling the engine, meaning a road speed of approximately 24 kilometers an hour should be reached before full engagement, before placing the gear into selection and place. During this time, the tractive effort would be greater than force opposing the motion of the vehicle resistance. Figure 1, we can see, if we focus on the arrows, we can see the path in which the gear is selected between the first and third gears. We can see it's different compared to each other. The next problem that would arise would be the poor hill climbing ability. This means as soon as a hill is approached, the engine will slow down and eventually stall. This is overcome with an engine with a high torque output. Number 3, this vehicle cannot be driven at low speeds. As the vehicle is decreased, the engine speed will also be decreased, and slipping of the clutch will be necessary to avoid the stalling of the vehicle if the vehicle had to be driven at low speeds. And the last problem would be no neutral or reversing would be possible, because it's how the gearbox is laid out. In figure 2, we can see a typical 5-speed transmission system and all of its components. We can see the selection movement path and the gear lever bearing, the gear lever, the ball guide, the selector lever, the bearing pin, and the gate selector cable. And the double synchronizer then tells us before a gear is selected on the input shaft, it is engaged with a gear on the output shaft through what is called the synchro mesh body, and this sliding sleeve is firstly necessary to synchronize the gears during the gear shift via a taper on the gear and on the sliding sleeve of the synchro mesh body. The near doubling of the area of the tapered friction face increases the synchronizer performance by approximately 50% and almost halves the effort required for shifting gears. This results in an improvement in operating comfort during down changes, such as third gear into second gear and second gear into first gear. And figure 3 shows the housing of the body, and figure 4 shows both inner and the outer synchronizer rings and the tapered ring. We can see the sliding sleeve and the synchro mesh body for first and second gear in between there, and here in figure 4 we can see the inner synchronizer ring and the outer synchronizer ring and the change gear selector. Then we have the gearbox ratios. These are needed to achieve high maximum vehicle speed. Requires a system of gearing that allows the speed or the engine to operate at speeds at which it develops its best performance. The maximum engine power, torque, and economy will all occur at different engine speeds, so this has to be taken into account. Gearbox ratio is defined as the ratio of the number of revolutions per minute of the input source in relation to the number of revolutions per minute of the output source. It is known as the ratio of the gearbox, for example, the differential final driver ratio of a vehicle with an engine speed of 2,600 revs per minute. A ratio is 4:1 with a wheel size of a radius 15 and a diameter of 620. The calculation for the example for first gear is 3:5 equals to 3.5 by 4 equals 4 to 4.1 is to 1. To find the distance travelled in first gear equals the circumference, which is 2 pi r, which would be 2 by 3 by 3.14 by 0.3, and that will equal to our distance, which is the 1.884 meters. And in conclusion to the gearbox system, it is an essential part and engine of the engine makeup that helps with the vehicle speed and movement, and transitioning of the gears is a key part of allowing the vehicle to move and control its speed, especially when applying torque when challenged with an incline. And that concludes my presentation. Thanks.